Good afternoon and welcome to our fifth data camp session, Introduction to Python Coding and Databricks. Next slide, please. This session is going to be led by Derek Cruikshank. Just some administrative announcements before we get started. Please remember to stay muted with your camera turned off to minimize distractions. Also, please use the Zoom chat to ask us any questions or submit any thoughts you have. At the end of the session,
I think we lost Julia. I just wanted to add, I think she was going to start saying that any questions asked in the chat will be addressed by the session speaker at the end of the session. All right, so Derek, at this point, I think we'll hand things over to you to introduce yourself and your session. And you might be on mute.
Yeah, of course I'm on mute. Yeah, thank you, Rachel. My name is Derek Cruikshank. I'm a chief data engineer on the QDAS team. My background is much more in statistics, data science realm. I've mostly been programming in SAS and different types of SQL. The majority of my professional career, although the last handful of years, I have been sort of teaching myself slowly regarding Python and how best to utilize it specifically within the Databricks environment that we have available to us, and how we can manage large amounts of data regarding processing within specifically a Databricks compute cluster. Next slide. So the agenda of what I'm going to kind of demonstrate here is going to really be focused around not necessarily your basic, start off hello world Python types of, understanding data types and dictionaries and arrays and things of that nature, but really more how do you manage data, specifically within data frames, talking about the different types of data frames. I also want to demonstrate how you access data, whether it's through the CDR or through what a lot of SAS users and the user community refer to as a workbench, which is essentially just an AWS S3 bucket. And then, like I talked about, just kind of walking through how we utilize the different types of data frames to manipulate the data, to clean it, to aggregate it, to visualize it, and just kind of talk about other types of common packages and things that are very common among data analytics and data science within the Python community. So with that, I think I can share my screen. All right. And one thing to note is that all of these workbooks will be shared within the CCSQ community to all of the users. That includes Kyle's R notebook. These Python notebooks, we'll make sure that it's all shared and available and distributed so that users have the ability to see it. And another thing to note moving forward, we are working on creating a GitHub repository that will be shared amongst all CCSQ community that has a lot of different R and Python use case code snippets that users will be able to utilize when it comes to trying to figure out how to do certain functionalities and use cases within the Databricks environments. So to start off, I want to kind of talk about the different types of Python data frames. Essentially, what is a Python data frame? It's basically a matrix, right? When you think about my statistics background brings in linear algebra, which is a bit gross, I know, but it talks about matrix operations. And so the concept of having two-dimensional data structures, much like a SAS data set, is a Python data frame. Most common data frame, most common package with a lot of Python users is going to be your pandas data frame. It allows for a lot of functionality. I do have some examples here within this command prompt that Kyle talked about that utilizes a markdown, which is a really good way to kind of organize and structure your notebook so that you can see different table of contents as you go through a lot of the different things that are laid out within a notebook. Another thing to note is with a type of a data frame would be a PySpark data frame or a Spark data frame. This is going to be heavily favored over a Pandas data frame when you're talking about working with large amounts of data. The Spark data frame utilizes the distributive processing and computing of what Databricks has to offer when it comes to the Spark engines, the Spark compute clusters that it runs on. So it's going to run, it's going to be able to scale out wide with the amount of worker nodes and memory and processing cores when that data comes across. And it allows for the parallel distribution and parallel compute, which is going to significantly increase the speed in which you're processing data when you work with PySpark data frames. A newer package that is available, it's referred to as the Pandas API on PySpark, is basically a PySpark Pandas package. And that's going to be able to be really handy when it comes to users who do have a lot of knowledge and background within the Pandas package, because this does allow for a lot of Pandas syntax, Pandas functionality, but it does utilize the distributive nature of the Spark compute that Databricks has to offer. So it does also speed up the processing of that data frame and the data within it. So to talk about initially a Pandas data frame, right? It does have the ability to go out and import data from our workbench, which again is just an AWS S3 bucket. It does require additional packages, and there are some other functionalities and requirements that you do have to implement in order to actually read some kind of file type into a Pandas data frame within Databricks off of your workbench. Kyle mentioned the mount functionality. I'm not going to demonstrate it here, but that is a functionality that is going to be required in order to read directly from Pandas from your S3 workbench. For now, what I'm doing is essentially just generating a data frame that will then be put into a Pandas data frame so that you can kind of take a look at the different functionalities of what Pandas has to offer. So by creating this dictionary, you can see I'm then loading it into a Pandas data frame using the Pandas package. One thing to note is the import statement, right? Bring in the Pandas package. You just have to simply import it. You can call it as some kind of a reference, and then when you go to call it, it's basically using that Pandas package that you've imported into your ability into your notebook. Another thing note around the user interface that Databricks does have to offer is that you do have the ability to see what kind of Python libraries are already pre-installed. Over here in this little book, it shows you all pre-installed Python packages. And so what this means is you can import them as you need. There's no necessary reason to have to pip install them. You do also have the ability to pip install packages that are not pre-installed. And if you do have requests where maybe you want to get a package installed permanently on your compute cluster, all you have to do is reach out to the DNA team with that particular request of the package, and it can be loaded specifically on your organization's compute cluster so that you don't have to pip install it each time you want to run it. One thing to note here is just a couple of different ways to kind of display your Pandas data frame. Here, it's just a simple print that I'm running where it's starting off by just simply printing it to the output. There's also the ability to display it. This is functionality that has, it's a little bit nicer, a little bit cleaner. If you prefer seeing it in more of a data set type setting, it does give you a little bit more functionality when you do display it versus just simply printing it. So really that's what I'm going to talk about regarding the Pandas data frames at this point. There is a ton of packages and functionality that are available within Pandas that are all out there available to explore. What I really want to focus more on is going to be the Spark data frames or the Pandas API on Spark data frames, because that is what we do want to kind of push as far as best practices when it goes to accessing data from the CDR, accessing data directly from your AWS S3 bucket with your Workbench. And when it comes to processing really large amounts of data, it's going to give you the distributive compute processing to make things run significantly faster than if you are operating everything on a Pandas data frame. So this example here shows how you can directly pull data from the CDR. I'm using a simple public data schema. And again, for those who aren't quite familiar with the user interface of Databricks, you do have the ability to view the catalog, where it's going to show you what you have access to regarding the CDR and all of the different Hive schemas and the tables. And it's going to be able to really allow for you to view and filter on certain things that you might be interested in seeing, your metadata as far as what the table schema is, details around the actual table itself, and even the ability to take a look and view at what the sample data looks like within the table before you're able to, extract from it. So what I'm doing here is simply utilizing what's referred to as Spark SQL to be able to pass actual SQL language to extract and place data that we're extracting from directly into a Spark data frame. Again, here I'm showing you a couple of different methods on how you can display the data within your data frame. Within this first cell here, it's simply doing a show output, and then I'm just simply limiting the number of records that I want it to print out to the top 15 records within the Spark data frame itself. You'll notice, it's not the greatest output to visually look at, but it is a quick and dirty way to be able to kind of produce it and see it. Another thing you'll notice here with Spark data frame is that it does give you your schema immediately after you load it into that Spark data frame, and it is identifying the data frame type as a PySpark.SQL data frame. So that is one thing to be able to note. And here, if we do want to display the Spark data frame in a little bit of a nicer fashion, we have this ability to run that display on the data frame object itself. This automatically will print out up to 10,000 rows, but it does give you a little bit of a more data set type structure if you're used to SAS, or if you're used to like an Excel type spreadsheet output. This is a better way to kind of view the data, be able to manage it, to manipulate it, and view it. How we can simply write back to CDR table, right, is just calling your Spark data frame. And it's as simple as identifying a write statement, and then you're saving it as a table. And then you're calling the Hive database or schema that you're wanting to write it to, and what the actual name of the table is that you're wanting to output to. And you notice the mode overwrite option that I've got set here. This allows us to be able to not have to go in and delete the table prior to writing and creating the table. This is just going to say if the table exists, we're going to overwrite what's there with the data that is in our current Spark schema here, or Spark data frame here, and it's just simply going to write it out and give us the knowledge that it successfully wrote it out. And you can then again go in and view it within your actual catalog if you're wanting to take a look at exactly what it wrote it out as with the metadata and the sample data to be able to view that. Another very, very useful way to be able to access files directly from your workbench, like you would do with SAS, you have the ability to directly read in those files from your S3 workbench utilizing Spark. So again, I've got a CSV file out there called member states. There is a SAS function, a SAS macro that will allow you to execute the macro within SAS to show you how your workbench maps directly back to the S3 bucket location. And that can give you exactly the path that you need to include on the Databricks side so that it knows to go out to S3 rather than going out to something that maybe SAS users would recognize as workspace, workbench, and then your org workbench name, and then data. Databricks is not going to recognize this because this is mapped directly back to your S3 object workbench location. So here, again, I'm just going to go ahead and read this CSV file that's saved on our S3 bucket into a Spark data frame, and then I'm just going to display the Spark data frame. It also gives you the capability to write back to your AWS workbench. Again, it's the right options here that we're writing, and we're just telling it to write it back out as a CSV. We do want to keep headers, and then the mode of writing it is just the overwrite option. So if the CSV already is out there and exists with this name, it's going to go ahead and overwrite what is there with the new Spark data frame that we're calling. There is the ability, I do want to talk about with the nature of Spark and how it is distributive with compute and with the data itself. If your Spark data frame is large enough, it will automatically write out multiple CSVs to your AWS S3 workbench location. There is a way to force it to only write to a single CSV. However, we would not recommend using it unless the Spark data frame is a small enough amount of data so that it's not causing some kind of a bottleneck within the processing of writing it all on a single cluster. I would highly recommend and encourage users to use the distributive nature when writing the data set out in order to be able to simply take the ability of the distributive nature and it's going to process it much faster when it's writing it out. One thing to note, again, about it writing multiple CSVs, how this is going to show up on the back end is a little bit different. What this is going to output is actually going to be a directory with the name of the CSV file that you wanted, and then there's going to be some crazy named weird actual.csv file. There is the ability, and there is code here that we've got that will make sure is passed amongst users to be able to say, okay, I don't want that crazy CSV named file under this. I want it actually to be named what I specified it as. It also gives the ability to say if there were multiple CSVs that were output by Spark, it's going to wrangle all of them up, combine them into a single CSV file, and then it will rename it. So this CB utils func method essentially is going to be really big to be able to utilize when you go out to your S3 bucket and essentially create and utilize it as a sort of file system. So this dbutils.fs allows you to run certain types of file system operations. And so what you can see here is I'm simply telling it that there are CSV files within this directory. It's going to go out and it's going to loop through every single CSV file within that directory and store them into a single CSV file. It's then going to move it up a level so that it's output where I initially wanted it. It's going to delete the old directory, and then essentially it's going to rename what you want it to be named. So utilizing this functionality here with your output is going to be really important so that it gives a single CSV file with the name that you're expecting in the location that you're expecting it to be. And there's lots of documentation, especially on the Databricks documentation site, regarding the capabilities of this DB utils functionality. And there is more than just the file system functionality that you can utilize. Now I want to talk a little bit more about that Pandas API on Spark, or what we can refer to as Spark Pandas. It is its specific package that you do have to import, but it does allow you to utilize the Pandas syntax and the Pandas functionality while also utilizing the distributive nature of Spark. So if you're familiar with Pandas, then you're very familiar with the read CSV option in order to import that into a Pandas data frame. Here we're using PySpark Pandas read CSV option. So again, I'm using the exact same CSV that I wrote into a Spark data frame. And now I'm going to write it into a Spark Pandas data frame. And basically how we know it writes it into a Spark Pandas data frame, again, is that we have this type class that I'm printing here around my data frame. And you can see here the class is PySpark.pandas, and that is the data frame. And so now I'm displaying it, and you can see it's basically the exact same thing, except rather being in a Spark data frame, it's now a PySpark Pandas data frame. Again, does have the distributive nature, just like Spark, because it's utilizing Spark, where again, we're using a toCSV call, which is very similar in exactly how you would do it on the Pandas side. Again, we're outputting our headers, and this will do the same functionality that it does with just a regular Spark data frame, where it's going to output specific weird CSV name within what you wanted to call the CSV file. It's going to be a directory, and if the data frame's large enough, it's going to write it out to multiple CSVs. So again, here you can see it's using that same sort of functionality where we're gathering up location and all of the CSV files within it to then rename them and combine them and move them up to where we want them to be. So there is a way that we can go ahead and convert data frames from a lot of different types, right? We can convert Pandas to Spark, Pandas to a PySpark Pandas. We can convert Spark to Pandas. It's definitely something that we would only recommend doing when you're working with a fairly small enough size of data, or if you need to utilize something that's very specific within the Pandas package that's not offered on the Spark side. But definitely this kind of allows you to take a look at the different ways that you can convert different data frames to other types of data frames, right? So all of these is just a different combination here of what we've initially had and converting them to something new. And here I'm simply printing out the type of each of these new data frames in order to show we had this Pandas data frame, we wrote it to a new Spark data frame, and now it's showing that it is Spark SQL data frame. Same with Pandas data frame being written to a Spark Pandas data frame, where it's now a Spark.pandas data frame. So this is a good way to be able to convert your data to and from different data frames based on the types of functions and things that you're wanting to run on that data itself. All right. So actually working with data frames, the vast majority of what I'm going to move on forward here with is going to be utilizing specifically Spark data frames and PySpark Pandas data frames. I'm not going to be utilizing just regular Pandas because I want to show sort of the different syntax between utilizing Spark data frames and how you can utilize the PySpark Pandas data frames, because that does have a very similar syntax nature of what the Pandas package does have to offer. So first off, I'm going to create my Spark data frame. I have a CSV file that I loaded to my workbench or my S3 bucket here that I'm going to just go ahead and import into a Spark data frame and display it. The actual data set itself, I downloaded off of Kaggle, and it's data regarding billionaires. So why not look at, the richest people in the world, I suppose, and how they got that way. So you can see here, simply reading in the CSV, Spark data frame, printing out the type. It is a Spark data frame, and then I'm using that display function to view the actual data itself. And now I'm just going to do the same exact data set, except I'm going to write it into a PySpark Pandas data frame. Again, importing that PySpark Pandas package and just using the normal standard read CSV, which is a little bit different than that Spark read syntax. Again, here we can see this is a PySpark Pandas data frame, and using the display option to be able to view the actual data frame itself, the data itself. Next is how can you view schema information around a data frame? It's going to be a little bit different between working with the Spark data frame versus working with the PySpark Pandas data frame, which is why I'm going to show you a little bit about how we're doing this. The first way is what I want to see is I want to see the number of observations of my data frame as well as the number of columns. So here you can see I've got my SP_DF, which is the data frame name for my Spark data frame. Using the count method, it's going to give us the number of observations within the data frame. And then using the length function of this columns method, going to then output the number of columns that I've got. The last piece here, you can see I'm importing some SQL functions where I'm going to go ahead and I'm going to count the number of columns that I have that have null values within the list of columns. So here you can see it's simply going to say, all right, I've got, a little over 2,600 observations, 19 columns. And then for each of the columns, it went in and counted the number of fields that are not missing within all of the available columns of my data frame. And here is where I'm showing it. And here you can see what fields have missing values compared to fields that have no missing values. And then the last thing I'm doing here is simply a schema, and that's going to tell me exactly what data types each of my columns are within my data frame that I've got. So you can see here, I actually went in and it is assigned every single one of those fields as a string value. And the reason why it did that was because I did not include a specific option I'll show later on in the demo, where it can infer the schema and assign specific numeric integer values instead of assigning everything as a string. On the PySpark Pandas, outputting the schema information is a lot more straightforward because it has that built-in Pandas functionality. So we want to see the number of observations and the number of columns within our data frame. Well, all we have to do is print the data frame's shape option. And then also, if we want to see the output of the schema, as well as we want to output the number of non-missing observations, like I did up here, we have that ability. It's much straightforward and easier with a PySpark Pandas data frame, as all we have to do is simply print the info on the data frame itself. So you can see here is simply outputting everything very, very much what we output up here. It's just a lot more straightforward because Pandas does have a lot more built-in functionality rather than what PySpark has built into it regarding the actual schema of a data frame. So here you can see the columns listed out, the number of non-null counts, and then what their actual data types are. Here you can see I do have some differences. I've got some values here that are integers versus objects, which an object from a Pandas perspective is just simply bringing it back to a string value versus an integer would be some sort of integer. 32 would actually be a long integer. What I've identified here is that we've got a little bit of differences within the two data frame schemas. So how we can update the Spark data frame to include the correct data type that we want so that the two data frames match is, again, importing some PySpark SQL package called types, where I want to set one of the columns equal to a Boolean. So it's just true or false, essentially binary, 0 or 1. And the other ones, I'm casting them as an integer type. So that you can see here, rank, final worth, and age are all numeric values. However, they were assigned string. So here I'm going to go ahead and take my Spark data frame and simply update the actual column itself by casting that same column to a specific data type that I want. And you can note here that to put this a little bit more structured within Python, specifically within PySpark, it allows for this backslash so that you can go down to the next line. If I don't have this backslash in, you're no longer following the required syntax that Python needs to have, and it's going to error this out. So you don't want to put everything on the exact same row. You can simply just do space, backslash, and then start on the next row to kind of call it out here, make it a little bit more readable to say, all right, I'm modifying rank, modifying final worth, modifying age. And then the last field I'm casting as a Boolean type, which is called self-made. Writing all of this to a brand new Spark data frame. And then I'm going to go ahead and print that Spark data frame to see exactly what it created and what it's going to output. Again, I've got same number of observations, same column counts that I did with the count function and the length of the column option. And then I printed out the schema again to be able to see, okay, we now have, these are no longer string values, they're now integers. And we can see that self-made is no longer string, it's now a Boolean value, set to true or false. All right, moving on, how we can run summary statistics on data frames. It, again, is a little bit different between a PySpark data frame and a PySpark Pandas data frame. Here, it's simply running a summary function on the actual modified Spark data frame and displaying it. And you'll notice here that it automatically outputs summary statistics for all of the columns, whether they are numeric or of a string type. It's going to automatically create it for all of the columns. Down here, when we're running a describe function on our Pandas, Spark Pandas data frame, it only defaults to running those summary statistics around those columns that are of an integer or numeric value. So that is one of the differences here. There is a very easy way. If you want to simply select specific fields to run this on, then you can just do a simple select statement, which I'll show you further down within the demonstration. But here, again, really just your summary statistics, counting your quintiles and some of your distributions around the mean. So for actual categorical variables, if we want to see the different values that make up each of the categorical variables, and maybe we even want to determine what is the distribution of the values. This is going to be, again, a little bit different depending on the data frame you're using. Here, we're going to use our Spark data frame. I've created a list of the character columns that I want to basically loop through one at a time. And essentially, all I'm going to do is for each one, I'm doing a group by statement here where I'm aggregating the count of the observations. And then I'm also taking that count and I'm creating a percentage as well to display the results one character at a time. So if we wanted to just simply run this on one field, we could call category here. And this will output, it'll loop through just the one simple categorical variable. Of course, it's not going to work now. And I forgot my brackets. So now we've got one distribution output of one field, but we want to see all of the categorical fields loop through one at a time. So it's just going to go ahead and do that with this for loop and output category, industries, self-made. This is the Boolean value, true or false, status, and gender. Unfortunately, you can see here, there's a lot more males that are billionaires in the data set than there are females, which is unfortunately a sad case. As far as the PySpark Pandas data frame goes, it's also going to do the same for loop here. However, we're doing it a little bit different here, where we're going to output what's referred to as the value counts of the data frame itself. And then we're going to write them back to a new Pandas or Spark Pandas data frame, where we can output the actual values, and then take the values and the sum of the values to create that same exact percent. Again, here we are using NumPy, which is another very common array type functionality package within Python that you would learn. And it works very, very well in hand with Pandas. And simply we're using it in order to be able to create a NumPy array on our actual index value that we're outputting each of the unique values of the fields to. So again, here, this is basically creating the exact same output as we created up here with our PySpark data frame, except that we're creating it with our Spark Pandas data frame. Realizing I have been rambling and mumbling, and I'm not incredibly as far as I want to go through, I'm going to kind of work a little bit faster here. We do have the ability here where I'm showing you how you can sort the different types of data frames. There is a little bit of a difference here again between Spark and Spark Pandas, where we're calling more of a sort function here versus the sort values ability or package, or not package, but call. And again, we're just simply displaying it where we're seeing, the data frame sorted by. Automatically, it's going to be sorting by the lowest ascending, so lowest to highest final value worth of the billionaires. If we want to sort it and write sort to a new data frame, we can do that. We can also sort by multiple fields here. And we can specify whether we want to sort them by ascending or descending. Again, here we're using the simple sort function on the actual Spark data frame. And here it's going to sort by category, and then it's going to sort a second piece of it by a descending final worth, so that we can get the highest, richest billionaire, I suppose you could call it that, and by each category. So by doing that within the Spark data frame, as well as the Pandas, again, it's a little bit different. We're simply, again, calling it the sort values object, and then calling a list of the fields that we're wanting to sort it by. And then here it's an ascending option, which is a Boolean option, and it's going to go in the exact same way that you're listing categories. So again, we're setting the first field ascending, and the second field is false, so it's going to be descending. So again, we are doing the exact same thing with the Spark Pandas data frame. And again, we're writing both of these data frames to new data frames. So here now, shockingly, we're going to use that new data frame that we just wrote to, and we're going to remove duplicate observations. So here is with Pandas, with Spark, it's a drop duplicates call, and we want to drop duplicates on the category. So what are we doing? We're simply getting brand new Spark data frame that lists all of the richest billionaires for each of the unique categories, which there were 18 unique categories within our distribution output of the category field. So now we've got 18 rows, all with incredibly rich people. Regarding the Spark Pandas, it's again a little bit different, where it's drop underscore duplicates, but we are calling the same exact field. And here we're just simply saying keep equals first. So we want the first record of each of the categories to be kept within this new data frame we're outputting to. And again, here you can see we've got 18 output rows, all with incredibly rich people. How to create new fields within a data frame. Here we can create a field which would simply be a binary field. Whether or not you are greater than or equal to 65 years of age, we're going to flag it as a 1. Otherwise, we're flagging it as a 0. And then here is that select statement where I'm only wanting to select these specific fields within my data frame that I am outputting show. So again, here is my modified data frame, the with column functionality, where I am calling a when function. So it's when it's just a simple case when statement within a SQL, right? Is essentially all that this is doing. So now we can output up 10 rows, and you can see here their age. If it's greater than 65, they've got a 1, otherwise it's a 0. How we do this on the Pandas side is a little bit different. We're going to use the low-C functionality here, where we're basically creating and saying, all right, we want to set new field equal to 1 if this is met, and then we're writing the exact same thing, set it on the other side. So it's a little bit not as straightforward when it comes to Pandas or Spark Pandas as it is with Spark, with some sort of a when statement here. But it's going to ultimately create the exact same output that we want, which is a new binary field called age 65, where it's a 1 if it's greater than or equal to 65 years old. Create something that is more than just a single binary field. So we want to create age categories. We can create a new column, right? And it's again the same exact thing with column, and we're using when statements and setting certain values all the way up to however many age buckets we want to create. Again, you can see here the backslash in order to kind of keep this a little bit cleaner, to see all of the different age categories that we're setting and what the criteria is that we're utilizing. So here we're creating a brand new Spark data frame. And then from that, we're selecting only the fields that I want within this list and showing the top 10 observations of the data frame. Exact same thing here that we did previously, where we are now just creating all of the different age bucket values that we're wanting to create based on the age logic. And then here is a little bit of a different way to be able to select specific columns in your data frame that you want to output, rather than actually calling a select function. It's just simply calling your list within the actual data frame object itself. Again, it's this head functionality with 10 is just simply telling us we want to output the top 10 rows, which matches exactly with that. This is going to be filtering data frames, and I do want to speed this up a little bit to save some room for questions. But it does have the same functionality here, where we are applying this filter function based on if that age bucket is equal to the bucket of greater than or equal to 80. So by running this, it's just simply keeping all of these columns from the data frame and any observation in the data frame where the age bucket was greater than or equal to 80. Same exact thing here. This is using, again, the LOC method where we're setting that age bucket equal to greater than or equal to 80. And we are only selecting and keeping the specific columns that we want. And by displaying the new data frame, we've got the exact same number of rows and the exact same output between Pandas, Spark Pandas, and Spark. Pending the data frames, this is simply using what's referred to as a union function. Those of you who know SQL know that when you do a union on two data sets, it's essentially just appending them together. And we're actually calling an append function when it comes to the Spark Pandas side of it. And here you can see, again, we're filtering out those that are not equal to that group. So basically, we just broke up the data set and we're putting it back together. For purposes of time, there is, merging and joining Spark data frames. Here, we're creating some really basic data frames just to show you kind of how you can join the different types of joins and merges within the Spark data frame, as well as how it works on the Pandas side. On the Spark side, you're simply joining it, telling, what are your data frames that you're joining with, what are the fields you want to join on, and what is the type of join. You'll notice here, initially, it's going to automatically create duplicate fields that you're joining on with the category. To be able to drop that is a simple drop statement saying we want to drop the second data frame we're merging on category in order to only keep what we want and not have multiple fields. On the Spark Pandas side, it actually automatically will coalesce your field that you're merging on. Again, here, it's a little bit straightforward. You're simply a merge function telling it which of the two data frames you're merging, what you're merging on, and what the type of merge you want to use. So this, you'll notice by running it, will automatically only keep one category column that you don't need to drop the second one. For a left join, it's the same exact thing, except you're calling it on the left side, so that you're keeping every observation in the data frame on the left side of your join. And then you are bringing in those that match from the other side. And you'll notice, we don't have fully matching values. They're null. You do have the ability here in order to do a null fill, where you can say, all right, if the color is, if there's no match on the category, then set the color equal to pink. And again, you've got two categories here, so we're just dropping that second category field. And you can see we've got everything listed in our left data set, and anything that was missing is now being as pink. Same way to do this here on the Pandas side is by using this fill NA functionality method. And again, we're setting it to equal to pink. So now, again, the category field automatically coalesces and drops the second field. And now you can see the exact same output. The full outer join here is going to be keeping everything from both data frames, as you can see, but you do have the ability here to coalesce the categories. And then if there are missing values within the number or within the color, you can see here, we are simply calling that out and saying the color field, we want, if it's null, set it to pink. Number field, if it's null, set it to 9. Simply outputting that gives you that ability. And on the Pandas side, again, it's the fill NA functionality where we're telling it again on the color and on the number to fill it and what value to fill it as. This gets a little bit into transposing. I'm going to blow through this, not talk about it too much so that I can get a little bit more into actual visualization piece here. I'm going to go ahead and bring this new data frame in again, and I want to show the capability here within the user interface of what Databricks has to offer. You can see here it imports this table, but there are some visualizations that I've already pre-created. This plus sign here allows you to add visualizations where it actually brings up the visualization editor on the data frame itself. And it's simply a drop and click where you can create all of these different types of data visualizations and telling exactly how you want it to look. So you can see here created visualizations through the user interface, where the first one is just a histogram of the age, and it does have the interactions of seeing exactly what it's doing. Second visualization is a bit of a scatter plot where we're looking at age and how that relates to final worth. You're looking to try and predict age based on final worth. You can see by the scatter plot, there's really no correlation there. And the last piece here is a little bit more of breaking out all of the categories and what their average final worth is across whether or not they were self-made. I've got the exact same syntax below here within the workbook that allows you to show how we can create these same visualizations utilizing matplotlib, which is a very common library of how you can utilize and modify different types of visualizations. Specifically here, we're using a PySpark distribution explore package that we're importing, and specifically we're importing the histogram package. So what you can see here is, sorry, I've not actually installed the module. I don't know where that went, but you can install the module and then run this, and it would print out that histogram. The pandas side here is how I'm importing my PySpark data frame into a pandas data frame and utilizing the pandas plot functionality. Here, I'm simply creating the scatter plot again of age and final worth, and I'm actually using the figure size in order to make it a lot bigger than what it would normally output it to. And the final piece here I want to talk about is another package called Seaborn that you can utilize again with the matplotlib, where we are simply taking the pandas package. We're aggregating the mean of final worth and then creating the categories that we had and what their average final worth cost is, and then breaking them out between whether or not they were self-made.
Hey, Derek, I did just want to give you a quick time check.
Yeah,
We do need to wrap up in about 1 minute. No,
really
that's okay.
Blew through that. Yeah, certainly we can try and answer some questions or answer them offline if possible.
Yeah, since you are presenting in the next session, I do want to give you like a quick minute to, do anything you need to do between. But all questions will be answered in our Q&A space on our DataCamp Confluence page. So they'll be published there and then answered there as well. So at this point, we are going to close out our 5th session. Derek is doing our next session as well, which is going to be Python coding for SAS programmers. And that's going to be starting in just 2 minutes. So at this point, we're going to take a quick 2-minute break and then come back at 3 p.m. for Derek's next session. Thank you so much. I really appreciate it. And we'll talk to you in just a couple minutes.